All right, compare the graph of each function with the graph of the square root of x. Then sketch each graph. This is lesson video part 2 of 1.7. So we're just going to use words to describe. This negative sign here means it reflects over the x-axis. This 2 means it's shifted, translated, left 2. So I'm going to sketch this graph, and when you have a square root function, you're going to want to make sure you limit the domain. So shifted over the x-axis, left 2, so I'm going to go left 2 first. Over the x-axis, it's going to look like this. And we should probably include a couple other points. So this one would be a point here. If you go over to the left 1, down 1. And then if you go over 2, 3, 4 more, down 2. And then our domain, x can be negative infinity all the way until 2, and we can include 2. Sorry, not 2, negative 2. All right, for the next one, there's a couple different things happening. There's a negative sign in front of the x and a subtracting 1. The first thing you're going to want to do is factor out a negative 1, and you'll be left with x plus 1. We know that negative 1, since it's inside the square root, is a reflection over the y-axis. And now, because it says x plus 1, we know it's shifted to the left 1. So the first thing you're going to do is apply the reflection to the y-axis. So we have our graph, and now we're going to reflect it over the y-axis. So our point that was 1, 1 is going to be negative 1, 1. And our point that was positive 4, 2 will be negative 4, 2. Then we'll shift the graph to the left 1, and the point that was negative 1, 1 will be negative 2, 1, and the point that was negative 4, 2 will become negative 5, 2. And we'll have our 3 important points. The next one also has a reflection, but because it happens outside the square root, it's going to be a reflection over the x-axis. And then a vertical shift up 3. First thing you're going to do is reflect over the x-axis. So you're going to take your regular parent function and flip it over the x-axis, so the point that was 1, 1 will become 1, negative 1. Then you'll shift it up 3. So 0, 0 will become 0, 3. And the next point will be over 1, up 2, and you can get your function that way. The last thing you need to remember is that a square root function changes the domain. On the last example, I forgot, and it should have been negative infinity to negative 1. And on this example, it'll be the same domain from 0 to infinity, including 0, so I used a square bracket. Non-rigid transformations. These transformations change the shape of the original graph. So if c is the multiplier happening outside of f of x, this is going to happen vertically, and it's going to stretch if c is greater than 1, and shrink the graph vertically if c is between 0 and negative 1. If c happens inside parentheses, and it's happening to the x, then it will be a horizontal stretch if c is between 0 and 1. So you have to think opposite again, and a shrink if c is bigger than 1. Compare the graph of each function with x squared. So this 4 happens outside parentheses. This would be an example of a vertical.
Hey, good afternoon. Can I have your attention, please? Attention, please, all staff and students. Just an announcement. The home football game that was going to be played tonight at Highland has been moved to Two Rivers High School because the field is soaking wet from all the heavy rain today, and if we played, the field would be destroyed. So the football game that was going to be at Highland tonight at 6 p.m. has been moved to Two Rivers High School. So just wanted to let you know that. Students do not stick around after school for a game because the game will not be held here. Okay, and just a general reminder, the game is at 6 p.m. at Two Rivers. And just a reminder, students, unless you're here for a club or a sport, you cannot be in the building after school. Thank you.
Okay. So because the 2 happens in, oops, I'm on the wrong example. Because the 4 happens outside of parentheses, this will be a vertical stretch by a factor of 4. So this graph should appear narrower. And you can plug in, your points, 1, multiply it by 4. It's going to go up to 4, -1, up to 4. You can have a slightly narrower graph, vertically stretched. Whereas this one is still a vertical stretch. Sorry, vertical. It's still vertical, but this time it's going to be a vertical shrink by a factor of 4. And this one would look like, instead of up 4, up 1/4. So it's going to be quite a bit wider. Okay, compare the graph with the function f of x equals 2 minus x cubed. So with this one, I'm substituting this in for x in f of x. So this is going to be 2 minus 2x cubed. And what will this do to this graph? Well, it's going to be a horizontal shrink by a factor of 2. So we're shrinking it because it's horizontal. It's happening in parentheses here. And so it's a shrink by a factor of 2. And what would this be? This next one would be 2 minus 1/2 x cubed. This would be a horizontal stretch by a factor of 2. Hopefully this was mostly review, and let me know if you have questions.